So if you don't know what derivatives are, then I would suggest not watching this video yet until you know what they are pretty in depth. But this video is going to focus on three things, mainly displacement, velocity, and acceleration. And displacement is basically how far away you are from an origin or starting point. And it's basically like the distance. So let's say if we have f of x equals your displacement, then f prime of x will equal your velocity, because velocity is your change in displacement. And if you don't know, velocity is kind of similar to speed, except you have direction as well. And f double prime of x, or the derivative of your velocity, will be your acceleration, or your change in velocity. And both these velocity and acceleration will be instant, not average, because, well, it's the derivative, it's the instantaneous slope. So usually you won't have something like f of x be your displacement, it usually be s of t, and where t is seconds usually, or some unit of time. And let's say you have s of 3 equals 4. Usually what this would mean would be at 3 units of time, or 3 seconds usually, you are 4 meters usually away from an origin or starting point. And another term you should probably know is your speed. And like I said, your velocity is similar to your speed, except it has direction. And all of these quantities have direction. Displacement has direction, and acceleration do too. Just negative or positive when we're thinking about a graph. But speed does not have a direction. So for example, if you have a velocity of 4 meters per second, and actually we write it as 4 meters times second, like this, because power of -1 means a fraction. If this is your velocity, then your speed would also be 4 meters per second. But if you had -4 meters per second as your velocity, your speed would still be 4. And basically, speed is just how fast you're moving, which is just the absolute value of your velocity. So just remember that. And if you would ever want to find your average velocity instead of instant velocity, then you wouldn't take the derivative. You would instead do just like a regular rise over run. For example, if this is the graph of your displacement and you want to find the average velocity between these 2 points, you would just find the rise over run and then calculate the slope. And same with acceleration, except you need to take the first derivative but not the second derivative, and do the same thing. So for example, let's say we have this function of velocity v of t is equal to 2 times square root of t plus 3 centimeters per second. And this is our unit of velocity. When t is greater than or equal to 0, because you can't have negative time. And let's try to find the function for acceleration, or instant acceleration. So we just have to find the derivative. So v prime of t is equal to 1 over square root of t. And that's basically it. That's our acceleration function. Acceleration is 1 over square root of t. And for this one, it would be centimeters per second over second, but we can't write this in division. We just centimeters to power of -2. And that's our unit of acceleration for this. And if you wanted to find the average velocity, let's say from t equals 1 to t equals 4, then we wouldn't use this acceleration function. We would just use this function, just using the rise over run. So first, let's calculate the rise, or the change in y value. So to find that, we need to find the y value when t equals 4 and when t equals 1. When t equals 4, it is 2 times square root of 4 plus 3, which is equal to 7. And when t equals 1, it is 2 times square root of 1 plus 3, which is equal to 5. So that means when t equals 1 to t equals 4, the y value increases by 2. So we have a rise, and we need to calculate our run first, which is pretty easy. It's just do 4 minus 1 is 3. So that means our average acceleration over t equals 1 to 4, or 1 second to 4 seconds, is 2/3 centimeters per second, or centimeters times second power of -2 is our unit. So let's say we have this function of displacement s of t is equal to t cubed minus 9/2 t squared minus 12t plus 5, and we want to find when it changes direction, or when the movement goes from right to left or from left to right. And again, this is our function of displacement, and if you think about it, when it changes direction, the velocity is going from positive to negative, or negative to positive, because positive velocity represents movement to the right and negative represents movement to the left generally. And in order to do this, we need to find the derivative of this to find the velocity function. So velocity equals 3t squared minus 9t minus 12. And to find when it changes from negative to positive or positive to negative, we set it equal to 0, because that's when it crosses over. And we get t squared minus 3t minus 4 equals 0. And if we factor it out, we get t minus 4 times t plus 1 equals 0. So t equals 4 and -1. And you can plug in values from before 4, after 4, before -1, after -1, to make sure that it actually goes from positive to negative and negative to positive at these points, and they do. But if you think about it, -1 cannot be a valid answer because we cannot have negative time. You can't go back in time. So that means 4 seconds, assuming seconds is a unit, is our final answer. So let's say we have this graph of velocity where our x value is t and our y value is v of t. And we're trying to find when it's speeding up and when it's moving right. So when it's speeding up, that means our acceleration is positive. And to look at this one, the acceleration is the slope of the velocity, or the instantaneous slope of velocity. And here is pretty easy to determine when the slope is positive. It's just when the function is increasing. And here is increasing from 4 to 7, or this portion of the graph. So it's speeding up from 4 seconds to 7 seconds. And it's moving right. When it's moving right, the velocity is positive, because as we said before, a positive velocity implies movement to the right, and negative velocity implies movement to the left, unless the question states otherwise. So to find when the velocity is positive, we just look at the graph. It's this portion, and everything before it is negative. So after 6 seconds, our object is moving to the right. So after 6 seconds. And that's our final answer. So everything that I explained and long problems that I went through should give you a general idea of how to use derivatives in kinematics and displacement, velocity, and acceleration. And this concept is not anything new in derivatives. It's just mostly learning what the terms mean. And as long as you know what derivatives are and what they mean, from the first derivative, original function, and the second derivative, then you should be able to do all this pretty easily. And also assuming you know what each term means. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.